All right, on to section 2.2 on conditional statements. So, the book's going to use some notation that we need to get used to. Okay? A conditional statement has a hypothesis and conclusion. Right? So, for example, if I use if an angle is right, then it measures 90 degrees. Okay? So the hypothesis is the if part. And then the conclusion comes after the then. The hypothesis for our book, we're going to use the letter P, and the conclusion, a Q. Okay? And if we have an if then, it goes like this. If P, then Q. So we use this notation. This is shorthand notation for that statement. Negation is the opposite of a statement. The opposite of a statement. We're going to use that symbol not. So in this case, for that not, I'm just going to do a squiggly mark like that. Tilde to refer to the not. So if I had the statement, Mr. Angelo is an awesome teacher. If I wanted to negate that statement, Mr. Angelo is not an awesome teacher. The converse of a statement, we're going to flip the hypothesis and conclusion. So this would go Q and P. We're flipping the hypothesis and conclusion. That is the converse of the statement. So if I'm using this one up here, if an angle is right, then it measures 90 degrees. The converse would be if an angle measures 90 degrees, then it is right. Notice how I just change the hypothesis and conclusion around and make sure I wrote it in a way that makes sense. Next, the inverse. We're going to negate the hypothesis and the conclusion. So this goes not P, then not Q. So in using my original example, if an angle is not right, then it does not measure 90 degrees. Questions so far? We have a lot of writing. Moving forward. The contrapositive is next. The contrapositive is flip and negate the hypothesis and conclusion. So the inverse of the converse. So this one goes, and this one is red, not Q, then not. So if an angle does not measure 90 degrees, then the angle is not correct. So what we want to do when we're going through these is determine the truth value for each of them. So our truth value will help us determine whether or not we can use this as a definition. So is this original one a true statement? Let's go ahead and look at this. If an angle is right, then it measures 90 degrees. That's true. What about this? If an angle measures 90 degrees, then it's right. Also true. If an angle is not right, then it does not measure 90 degrees. That's true. If an angle does not measure 90 degrees, then the angle is not right. Those are all true. Therefore, what we can say is that this makes a good definition of a right angle, right? That it measures exactly 90 degrees. What it means to have a good definition is that it's reversible. We can flip it around. So the next thing are equivalent statements. Equivalent statements are two statements that are both true or both false. So it turns out that the original conditional and contrapositive are equivalent statements, and the inverse and converse are equivalent statements. So we know if the original conditional is false, the contrapositive can be false. Or if the original conditional is true, the contrapositive can be true. And the same thing you said for the inverse and converse. The converse is true, the inverse is going to be true. Converse is false, the inverse is also going to be false. It's going to be the same. Yeah. All right, so for example 1, we want to rewrite these statements in the form of an if-then statement. The 2 points are collinear. If they lie on the same line, what we're going to do is if 2 points are collinear, then they lie on the same line. You try B. Take a second. See if you can change that to an if-then statement. Let's see how we did. If a number is divisible by 9, then it is also divisible by 3. Changing those to if-then statements. Try example 2. See if you can come up with a counterexample for each of the following statements. Remember, counterexample, we learned in the last lesson, is a single example that shows that a statement's not true all the time. If x squared equals 16, then x equals 4. And they would come up with a counterexample for that. A statement that says that's not always true. Negative 4. Very good. If an angle is acute, then it is 30. They would come up, yeah, go. If an angle is acute, then it is 30 degrees. So we need to come up with any measure of an angle that is acute, but not 30 degrees. What do you got? 40 degrees. 40 degrees. Yeah. 40 degrees will work perfectly, right? Is 40 degrees acute? Yes. But is it 30? No. So remember, we're trying to find something that is true with the hypothesis, but not true with the conclusion. All right. Next. Come up with a converse to this statement. Yeah. If a person lives in Sacramento and he or she lives in California, so what would be the converse? You want to say that aloud? Converse, what do? Flip the hypothesis and conclusion. The converse looks like this. If he or she lives in California, then the person lives in Sacramento. Is that true? Was the original statement true? The person lives in Sacramento and lives in California? That's true. But is this true? If he or she lives in California, then a person lives in Sacramento. If you shake your head and say it's not true, you need to come up with a counterexample. Luke, where do you live? Placerville. So Luke is an example, a counterexample to this statement. So Luke lives in P-Town and lives in California. So Luke checks that box. He lives in California, but he lives in Placerville, not Sacramento. So that would be a counterexample to that statement. Single example that shows that that statement is not always true. All right, I want you to try this on your own. Come up with the inverse, converse, and contrapositive of that original conditional statement. So, inverse, we're going to negate both the hypothesis and conclusion, put our knots in. The converse, we just flip the hypothesis and conclusion. And the contrapositive, we flip and negate. Take a few minutes to try that one out. Let's see how we did. So the inverse, we're going to negate both the hypothesis and conclusion. So here is my P. Here's my P. The inverse is not P, then not P. So if the measure of angle A is not equal 30, then angle A is not acute. The converse, that is Q then P. So this one, if angle A is acute, then measure of angle A equals 30. So flip our hypothesis and conclusion. And then the contrapositive, the inverse of the converse, not Q, then not Q. If angle A is not acute, then the measure of angle A is not equal to 30. So let's go through and put a truth value to each thing. First one, if measure of angle A equals 30, then angle A is acute. Is that true? Yeah, the original statement is true. So we know that the contrapositive also has to be true. So no. If angle A is not acute, then it can't equal 30 degrees. So that's also true. Let's look at the inverse. If the measurement angle A does not equal 30, then it's not acute. Can anyone come up with a counterexample of that? Yeah, if it's not 30, right, then it's not acute. It could be 40, right, and still be acute. This is false. Converse, if angle A is acute, then it's 30 degrees. Now we can think of lots of other examples where angle A is acute, but not equal to 30 degrees. So that's also false. So what we're getting at here is a way to come up with a good definition. Right? So I think we can all agree that if I wanted to define what an acute angle is, would it be enough to just say it's an angle that measures 30 degrees? No, that would be kind of silly, right? We can go through these to determine if something's a good definition by seeing if all four of these are true. If we get a case where 2 are true and 2 are false, then it definitely would not make a good definition. We would need more information. All right, so point, line, and plane postulates. So these are true statements, which are always true, and we can use in arguments. So let's look through each of these. Through any 2 points, there exists exactly one line. A line contains at least 2 points. If 2 lines intersect, then their intersection is exactly 1 point. Through any 3 non-collinear points, there exists exactly 1 plane. This is stuff we're doing in 1-2. A plane contains at least 3 non-collinear points. And if 2 points lie in a plane, then the line containing them also lies in the plane. And if 2 planes intersect, then their intersection is a line. What I'd like you to do is use this figure to see if you can go ahead and match up which one of these goes with the statement. All right, let's see how we do. So there's exactly one line that passes through points A and B. With points A and B down here, there's exactly one line. What number? Through any 2 points here exists exactly one line. That's just number 5 right there, right? Lines M and N intersect at 1 point. So we have lines M and N. They intersect at exactly 1 point. That point is A. So if 2 lines intersect, then their intersection is exactly 1 point. That's number 7, right? And then points A and B lie in plane P. So line N, which contains point A and B, also lies in point P. So that would be number 10, right? If 2 points lie in a plane, then the line containing them lies in the plane. Number 10. Our last example, right? Decide if the statement is true or false. If it's false, give a counterexample. So one of these is true, 2 of them are false. You need to come up with 2 counterexamples. So for example, this first one, through any 3 points, there is a line. Is that always true? No, right? I could have points A, B, and C, right? Where you could have more than just one line. So that would be the counterexample. This is false. And then there's my counterexample. The next one. If 2 planes intersect, and their intersection is a line. True or false? That was true. Right? Remember when 2 planes intersect, their intersection is always a line. This one is. The last one. If AB equals BC, then B is the midpoint of AC. That one is false. Okay. What if I had the point B? Okay. And C. Okay. So if AB equals BC, then B is the midpoint of AC. Midpoint of AC would be over here, right? That would be the midpoint of AC, not, that's false. So oftentimes the picture can provide us a better idea than just using words alone, coming up with counterexamples. Questions so far?